provide you a formula sheet on the test. It's like the last page though. It's not like the front spot like this. And I don't really give you any of these. You don't really honestly need to remember any of this part, but I do give you all of these and I don't tell you what they are. You kind of need to remember what they are, and if you're not sure and you want to go ahead and just write on this page what it is, I'm going to label them. Like this is your distance formula. This was the slope formula. This is your midpoint formula. This is slope-intercept form of an equation. We've talked about it a few times. Remember where m is the slope. Slope is with a p, not a b, and b is your y-intercept. Those are things that if you want to take just quick notes about them, to me it's like a very brief overview of some of the formulas. And then this one is called point slope form. Remember, this is the one when they ask you to find an equation. This is the equation you're going to use to plug those values in. It's the last thing we learned about in this unit. So those are just some quick notes. The last page will have your formulas on it, so you don't have to memorize them, but you do need to be able to recognize what they are and know when to use them. Because I don't say, here's the formula, use this to find the slope. I expect you to kind of know how to go find that slope. So you will have, like number 1, you're going to have an equation that you need to solve. So what's the first thing we do in number 1? Distribute, right. 2 times x is 2x. 2 times a negative 3 is a negative 6. What do I do with minus 9? Do I distribute to it? No, we just bring it straight down. It's being separated, right? So just bring it down in your line of problem. And then put your equal sign and distribute. 4 times x is 4x. And 4 times a negative 6 is a negative 24. Okay, before we start moving stuff around, do you notice like terms over here? Okay, remember, we're not moving it, so you're combining them with the signs they have. Okay, so just bring down 2x. So I'm just saying I want to combine these like terms, so that would be a negative 15. Negative 6 and negative 9 make a negative 15. Equals 4x minus 24. Now I have variables on both sides and constants on both sides. Right? So now we can start, I always say flip-flop. We just need to move stuff around. You can start in 4 different places. I'm in the habit of moving my variable to the left. Since that is a positive 4x, how do I move the whole thing to the left? Subtract 4x. So 2 minus 4 is a negative 2x. Because of space, I'm going to show, just with a different color, that I want to take my constant then and move it to the right. If it's a negative 15, then I have to say plus 15 or add 15. So that's going to this other side of our equal sign. So what's negative 24 plus 15? Negative 9. What do I do now to get x by itself? Divide, right? Divide by a negative 2. I'm going to do it right here since it's kind of squished. You'll have room to the right that you can write on. I kind of wrote over here, so I didn't on your test if you need to. So that gives us x equals, I can't reduce 9 over 2, right? Remember, I don't really want to see a mixed number. We've not done that all semester. I don't want to see a decimal really even though that would be an ending decimal. Let's clean up. A negative and a negative means that's a positive 9 over 2, and just leave it as an improper fraction. That's okay. Number 2, we have a fraction equaling a fraction. Remember, if you're working with a problem, the biggest thing, a problem that has fractions, the biggest thing is we just want to get rid of the denominators. We're not trying to change those denominators ever. So if you're tempted to be like, oh, I have to find a common denominator and change it, write yourself a note and say, no, I want to eliminate the denominator. I want to get rid of it first, okay? Since it's a fraction equaling a fraction, remember that shortcut of butterfly? We could simply butterfly this one for our first step. So we could say I'm taking, and I like to put the number that's by itself first, 5 times 2x minus 3 equals the other, basically like cross multiplication, 4 times x minus 7. But you need to make sure you have an equal sign between both of those. You guys remember that a little bit? Okay. So now we just simply solve it like a normal equation. It's a lot easier to deal with. So we say 5 times 2x is 10x. 5 times 3 is a negative 15. 4 times x is 4x. 4 times a negative 7 is a negative 28. So now we can't really combine any like terms on the left or the right, correct? There's term with a letter, term without. So again, I'm just kind of in the habit of moving, if I have variables on both sides and can, moving it to the left. So since it's a positive 4x, I'm going to subtract 4x. So 10 minus 4 is 6x. Again, just kind of showing this step similar like I did above. I want to move that to the other side. Since it's a minus 15 again, I would add 15. So you have an equal sign between. Negative 28 and positive 15 make a negative 13. What would my last step be? Divide by 6. So in this one, I don't have two negatives, so it is a negative answer, right? And I can't reduce 13 over 6, so I'm just going to leave it as that ugly improper fraction of negative 13 over 6. Extra thought. This might be a good extra thought. So I would write this down. If you have 2 over 5x plus 1 over 3 equals 2 over 3, could you butterfly that? No. Do I want to change the denominators? I mean, I just kind of made this one up. I wouldn't. You probably could actually, I guess, because you could move this over in their common denominators, but let's go ahead and just say this was a 5 for that purpose, so that you're not tempted. So just change it to 5. So like, you'd have to do a lot of work, technically, to solve that. If you do change it to a common denominator, you're welcome to. But remember in our notes we decided if we could get rid of the denominator, that's what we want to do. First step. It just makes it easier, especially if there's a lot going on the top. This one might be doable. But what can 5 and 3 go into? 15. So if you multiplied everything times 15, I just was squeezing it in there because I know sometimes we don't want to have to write a lot, and I did it with a different color to kind of help with that. If we were to multiply everything times 15, this is when you're cross-reducing and basically your denominator goes away for all three of those fractions, okay? And I'm just going to kind of set it up, but I'm not going to finish it. But like 5 goes into itself one time and 5 goes into 15 how many times? 3. So what you're multiplying together, because you got rid of that, is 3 times this 2x, because there's an x beside there, and you get 6x. So if you need to kind of circle that, draw attention to it, you can. Here we have 3 goes into itself 1 time, so we cross it out. And 3 goes into 15 how many times?
5 times.
5 times. So this is like saying 5 times 1. What's 5 times 1? 5. And so since there was a plus sign in between it, I put a plus sign in between. Here, 5 and 15 again. 5 goes into 5 1 time, and 5 goes into 15 3 times. So what are you multiplying together?
6.
Right, 2 times 3 is 6. And so this is just easier to deal with, and then you would finish. Just kind of reminding you of the first step of when you can't just butterfly. What would you do? Technically, what we learned in our notes was try to get rid of the denominator in the first step. If you end up working with it the whole time and get the right answer, that's fine. It's just that there's more space for errors when you do that. If there were binomials up here, you definitely wouldn't want to do that. Just a little bit of a review of what we learned in the solving equations with fractions. Number 3, those are absolute value brackets, right? Remember, it's tempting to want to distribute into that 5 to the absolute value, just like you did up here with the parentheses, but straight lines are not treated the same. They're not equal to like parentheses. They're not the same. So remember, we want to always isolate your absolute value bracket first. So that just means getting everything by itself by those rules that we learned with solving equations. So the first thing I would want to do is subtract 3. So I have 5, and the absolute value of 3x minus 6 equals 18 minus 3 is 15. What would be my next step to get those 2 straight lines, the absolute value by itself? Divide by 5, right? So what you have is the absolute value of 3x minus 6 equals 3. So this is where it needs to be before you start your 2 equations. So remember, we took a quiz on this, we kind of talked about that. A couple things we need to understand about absolute value is we always want to get the absolute value bracket by itself first. Then we got to decide, can we work with it? What does that mean? That means, is it equal to a positive number? And is it? Yes. So now, it's kind of sort of like 3 things. We need to make our 2 equations. 3x minus 6 equals 3. And 3x minus 6 equals a negative 3. So I am adding 6 to both sides. So we have 3x equals 9. And dividing by 3, so x equals 3. Adding 6 again, but this time negative 3 plus 6 is a positive 3. Dividing by 3, so x equals 1. So remember, like we said, absolute value, you need to, if the bracket isn't isolated, isolate it first, and then just remember you have 2 equations, meaning 2 solutions. So my 2 solutions would be x could be 3 or x could be 1. So if you will try to like box your answers out on your test, it makes it easier for me to find your work. Circle on something. For A, there will be a similar one on the test like that one. Honestly, I don't really have one like B. I'll finish it and I'll do B and you can check yourself, but these are directly from the notes. So if I want to get N by itself, that's why I have that semicolon and N. If I have N by R by T, that means you're multiplying, right? What's the opposite of multiplying? Dividing. So if I want to get N by itself, I just divide by R and T. So we have PV over RT equals N. You guys doing good so far that did your study guide before you came? Feeling pretty confident? Makes you feel ready for the test, right? Okay, let's turn the page. There's actually not one like number 5 on the test, but hopefully you did work it out. That is just like the one we did together in notes. It's on our notes. I'll finish that out and I'll have the solutions all on the same document in Blackboard if you want to look at it. We do have some inequalities on the test. Remember, this is one single inequality. It's just that you need to get x by itself. Okay, so don't get that confused with compound inequalities. This one isn't one. There's only one less than symbol. So that means I want to get all my variables on the left. So let's subtract 6x. So 9 minus 6 is 3x. I'll go ahead, since I have space, and rewrite plus 2 is less than 1. Then we would want to subtract 2 from both sides. So we have 3x is less than negative 1. What's our last step to get x by itself? Divide by 3. Do I flip the inequality symbol? No, because I did not divide by a negative number, right? I divided by a positive 3. So what we have is x is less than negative 1/3. And I'm just asking you on the test to answer in interval notation. So again, just trying to cut out the excess as much as possible this time, so you can focus on that stuff. I give you a number line and there's just a bunch of like lines. You don't have to be perfect. You can just come in here and call this negative 1/3. I don't need to see numbers before or after even. I don't care. I just need to know that you know that x is less than negative 1/3 means I'm using a soft bracket and I'm going to point to the left because that's less than, right? And it goes to a negative infinity. And the reason I do that is because this right here builds my interval notation. So I'll be looking for this to grade. I'll be looking for your graph, which I already have a number line on there for you to grade. And I'll be looking for interval notation. And so that would be saying negative infinity, comma, negative 1/3, and both of them have soft brackets by it. The next one is an absolute value inequality. So remember, that does create two equations, which would be like a compound inequality, right? So because this is already isolated and that's a positive number, we can go make our two equations. 2x minus 5 is less than 3. And just remember, the difference between inequalities and absolute value equations is that when you change the sign of this number, you also have to flip the inequality symbol. And there'll be a graph. We'll go to this in just a minute after we solve, and I'll just have numbers and you get to pick how you're going to graph it. So let's start solving. I would add 5 to both sides. So we get 2x is less than 8. And then we divide by 2. So again, I divided by a positive number, so I do not flip the inequality symbol. If I was dividing by a negative number, I would. We're going to add 5 to both sides. So 2x is greater than negative 3 plus 5 is a positive 2. I'm dividing by a positive number again, so I'm not flipping my inequality symbol. So x is greater than 1. So you do have all these lines. You can go be as particular as you want with it, but I could just say here, I'm going to call that 1, and here I might call that 4. I'm not going to be looking how many lines are in between and if that makes sense or anything. Okay, I just know 1 is to the left of 4 on the number line. Don't have to be incredibly perfect. But if x is less than 4, what I'll be looking for is that you have a soft parentheses and that you're pointing towards the 1. And if x is greater than 1, I have a soft parentheses and I'm pointing towards the 4. So notice they share all the numbers, all the possible numbers between 1 and 4. So this is not a union. You bring your integral notation straight down from your number line. So because I have a soft parentheses by 1, I put a soft parentheses to the left of it, comma, and because I have a soft parentheses by 4, I put a soft parentheses to the right of it. It looks like an ordered pair, but it's not. This just means between 1 and 4 are all possible solutions. So again, I need to see this. I need to see your solutions. I need to see your number line, and I need to see your integral notation. Everything that you see on there, you'll have to be able to do. But I don't make you write it in set builder notation. There's not one like number 8 on the test, so let's, again, just kind of cut the fat. Let's go to number 9. There is one like number 9. So if these were not your favorite, maybe make sure you pay attention to this one specifically. Practice it, read it. Practice setting up your, what I like to call your tic-tac-toe. So I do this, and it kind of looks like tic-tac-toe. And let's go read the problem, then come back to it. It says, an investment advisor invested $14,000 into 2 accounts. One investment earned 8% annual simple interest, and the other earned 6.5%. The amount of interest earned for 1 year was $1,021. How much was invested in each account? So again, we're talking about $14,000 in 2 accounts. We can call one account X and the other account Y. So that's why we put X and Y here every single time. No matter what you're reading about when we're doing investments, if it's saying 2 accounts, which it'll always just be 2, you're going to put an X and a Y there. The total amount invested goes right underneath that, $14,000. Be like your principal. Remember, we do kind of work with that interest formula that we talked about in our notes. Principal times rate equals your interest, okay? So remember, this is the percent column for your interest amount. But we don't write 8%, we turn it into a decimal of 0.8. So we can call, we're going to say account X represents the 8%. And account Y is going to represent the 6.5%. I know that already looks like a decimal, but it's a percent decimal. So you still have to move your decimal 2 places to the left and call that 0.065. There will not be anything in this spot. Then it says the amount of interest earned. So remember, this is like your principal times your rate equals your interest. Your interest will always go right down here. They want to earn $1,021, or they did. And so they're wanting to know how much money did you put in account X, how much money did you put in account Y for it to earn that amount. So remember, to get this over here, we just simply say 0.08x. 0.065y, and these 2 things become our 2 equations. Now you read it from top to bottom. I'm just going to kind of circle it. These are your 2 equations that we're going to use to start solving this problem. So if setting the tic-tac-toe up is a problem, maybe just go through, read it, and practice that. Then start practicing, okay, now I have a system of equations. I have 2 equations. I have x plus y equals 14,000. So you're always taking this plus this equals that bottom number every time. This other equation, put a line there so you see the difference between the 2 sides, 0.08x plus 0.065y equals 1,021. So remember, we're going to solve this by substitution. So my first step would be, hey, let's get x or y by itself in that first equation. I like to get y by itself, or x by itself. I like to move y, only because I don't really know why. I just do it. Doesn't really matter. If you moved x over, it'd be like saying minus x, right? So x equals 14,000 minus y. So you just rearranged that and got x by itself. So remember, we take this now and we plug it in for x. So we'll just have some y's and we get to solve for y. So 0.08 times 14,000 minus y, and then we rewrite the rest of that problem. Plus 0.065y equals 1021. What do we do next? Distribute. We want to get rid of those parentheses. So if I take 0.08 times 14,000, that's 1120. And then 0.08 times negative y is a negative 0.08y. Then we rewrite the rest of that problem that we didn't work with. So plus 0.065y equals 1021. That's a 0. I guess you couldn't even see my calculator. It's dark, so putting it up there didn't really matter. There we go. We do have like terms. You could plug this into your calculator if you want to. If you want to, I'm confident you could probably do that without. But just remember, if you do, and if you're plugging it in this order, just a little reminder about your calculator that for the negative, you need to make sure you push this one and not the minus sign. Otherwise, it will make like a syntax error. It's not going to work it for you. So negative 0.08 plus 0.065 is a negative 0.015. Negative 0.015. That leading zero, you don't have to put, but I just did that time because I said it. Zero came out of my mouth before point. What next, guys? Just solving an equation now.
Subtract 1120.
Yep, subtracting 1120. If you don't want to do any math in your head, that's really fine. I don't want to at 9 a.m. after having a late night last night. So you can just do that, negative 99. My son had a JV game, so it was just kind of a late night, and it was in Perry, and my baby was bad. He didn't want to go to sleep when we got home. So, it was busy. Okay, what do we do now? Divide by negative 0.015. We know this is going to be positive, right? It better be. Can you have a negative amount of money you're investing? I wish. Hey, I'm going to invest a negative $1 million. What's my return on that? Wouldn't that be great? No, we can't do that. So we know it's going to be positive, so I personally don't mess with my negatives in my calculator knowing it's going to be positive. So 99 divided by 0.015 is going to be $6,600 in account Y. Do you guys remember what percentage was account Y?
The 0.065.
Right, so you can come back to your little tic-tac-toe and you can say, I know this was my 6.5% account. You need to, you had to do that in WebAssign, so go back and just kind of make sure you're applying it to the real account in your mind, maybe label it. Actually, I think I have a place for you where it's set apart. Like, I want to know, like, which one was the 6.5% account and which one is the 8.5 or 8%. How do I find my 8? account amount. So I just go subtract. I can say I know X equals 14,000 minus what we now know of being 6,600. Right, so 14,000 minus 6,600 is 7,400. So X equals 7,400. Remember, this was my 8% account. So just go ahead and label it. Take a minute to label it. You know, obviously, if you are investing $14,000 only, if these two things don't add back up to be 14,000, you've done something wrong. So it's basically just trying to figure out, how do I divide this money up? And so in the end, after a year, what happened was those two accounts earned $1,021. We're not doing anything? I mean, I would take that. Okay, so practice this one. If you struggle, I would say this is probably the most commonly missed problem on the test. Prove me wrong. Make it not the most commonly missed one on the test. Go through and look at this one. The one on the test is pretty similar. Just gonna drop that hint. At least right now, it's pretty similar. So go practice it. Make sure you know how to work it. Go through those steps. I'm videoing this lecture right now, so if you need to go back and watch the lecture, you can kind of fast forward it until I get to that problem. You don't have to listen to the whole thing if you need to see that again. Let's go to number 10. We do have a distance and the midpoint that we have to find on a problem. Just make sure you don't forget, because it's between the two, you know, it says both. Sometimes people will do the distance and forget to do your the other. If you remember, the formula was over here and here. So that's given to you. You don't have to memorize it, but that's where I'm getting what I'm going to do next. So my distance equals the square root of, and kind of have a long line. Just got a couple things happening. My second x, which is -3, minus my first x, which is 5 squared, plus my second y, which is a -8, minus my first y, which is a -4 squared. So kind of see two parentheses there, but that's because I'm trying to separate that -4 from that minus sign for just a second. Technically, you could, if you're just careful with all your signs and everything, type that in exactly the way you see it, and it's going to take it straight to the reduced part. I would just make sure you do it a couple times. Check yourself, make sure you entered it all good. That way, I can't give partial credit if there is an error and I don't know where it happened. Okay, so just, I'm not opposed to using your calculator right there and just doing it, but I just want you to check yourself at least once or twice. Don't make a silly mistake in your calculator. I kind of am in the habit of doing some simplifying myself just for that reason too. So let's go ahead and do that. Let's humor me. So I know -3 and -5 makes a -8. -8 and a +4 make a -4 squared. Anytime you're squaring a negative number underneath that radical, it's going to be positive. It should never end up being negative, okay? Not in distance formula. It's always going to be positive. There's a mistake right there that I'm throwing out that I see a lot. It's how you're entering it in your calculator. Remember, if you don't know 8 squared, you need to put it in a parentheses, so you're telling your calculator the negative goes with the 8. Otherwise, it's going to do this, and you're going to write -64, and that's where you're going to have a mistake. So make sure you're using parentheses. That's all I want to say. So we have 64 plus 16, which is what? 6, 7, 8, 80? Yeah. So let's just do square root of 80. But we need to write this in radical form. Do not turn that into decimal, because you'd have to round, and that's changing the number. The radical is more exact. So you need to say, what is the square root of 80? And it's 4 square root of 5. This is why I really said we need the TI-30XS in this class, so that it will keep it that way. Otherwise, you have to go through and manually simplify that radical. If you forgot how, and you have to because you don't have the calculator, let me know and I'll see if I can get you some resources and you can review that. But since we're reviewing, we don't have a lot of time, let's just move on. My midpoint is a capital M, but remember all you're doing is you're adding your x values together, 5 plus a negative 3, and dividing by 2. It's like you're finding the middle by dividing by 2 between those two spots. And then negative 4 plus a negative 8, and then just divide by 2. So you'll have to do some simplifying. 5 minus 3 is really a positive 2 over 2. Negative 4 and negative 8 is a negative 12 over 2. So my midpoint, we need to simplify. 2 over 2 is 1. 2 goes into 12 6 times, so negative 6. So my midpoint between those two is 1, negative 6. I do provide a graph for you. I know on this review I didn't give you a graph, so when we do this, you're going to have to sketch your own little coordinate plane for just this problem, but on the test, I provide you a coordinate plane to graph, making it look a lot nicer for you. If we're graphing using slope-intercept form, remember we need to isolate y to do that. So we want to move 3x over by subtracting 3x. So I have a negative 2y equals a negative 3x plus 6. I'm not done isolating y, right? I need to divide by a negative 2. So negative divided by negative makes that a positive y. And negative divided by negative, you can barely see that negative, but remember that was a negative 2. Is a positive 3 over 2x, so my slope is positive. And then 6 divided by negative 2 is a negative 3. So you need to do this so that you remember, or so that you can find your y-intercept and your slope, right? So my slope is 3 over 2. My y-intercept is, if you're going to plot, start here, starter point, right? That's where you plot negative 3 on the y-axis. 0, negative 3. M represents slope, where you can think move. Move up 3 to the right 2 since they're positive, right? And you may need to kind of make yourself some little hash marks. So up 3, 1, 2, 3 to the right 2, 1, 2. And go ahead and do at least 3 points. Up 3, 1, 2, 3 to the right 2, 1, 2. We always did 3 points in our notes, and I just kind of like 3 points. I know WebAssign only required 2. I would like you to see 3. It just kind of makes a better line for me to grade. So if it says graph using slope-intercept form, that's what you need to do. You need to put it in y equals if it's not already in that form. I think it is on the test, but it might say f of x. What does f of x mean?
Function of.
The function of, let's say it looked like this, just for your, so just remember if it does say that, that's the same as saying y equals. We've talked about that, but if you kind of forget, if that f of x kind of throws you off, I don't want it to. Number 12, we do one of these, and I would say with the that one word problem we did, and this one are what I would say the two most commonly missed problems. And this one is so easy, it's just that we sometimes forget, what does x and y intercept even mean? So again, you're graphing this. This is where I want to know the point that crosses the x-axis and the point that crosses the y-axis only. I don't want to know other points. See how this one, I have a point here and here? Those would be the only two I want to know. So to make it really easy and organize it, we can use a T-chart. And what you do is you plug a 0 in for y and a 0 in for x separately, and you're going to have your two ordered pairs that way. This helps you keep your ordered pairs organized, and makes it really easy to identify when I'm trying to find what you're saying they are if I can't read your graph. Which I probably could, but go ahead and make sure you identify the ordered pairs too somehow. And if you have it in a T-chart, it's already done for you. Okay? So we're going to plug 0 in for y. So 3x plus 4 times 0 equals 12. So anything times 0 is 0. So to solve for x, we divide by 3. So x equals 4. So when you go plot this point, that's 1, 2, 3, 4 on the x-axis. That is your x-intercept. Now we're going to plug 0 in for y. So 3 times 0 plus 4y equals 12. So again, anything times 0 is 0. So to solve for y, we're just dividing by 4. So y equals 3. So when x was 0, y is 3, and that is my y-intercept. So I'm going to come up here, 1, 2, 3. Since x is 0, I don't move left or right. I just go up to 3 on the y-axis, and those are my 2 points. Make sure you draw double arrows on the ends too, making me know that I know that you know that these lines go on forever and ever. Okay, let's look at number 13. We do have one where we are working with functions. This was from your topic 2.2 stuff. It says given or if f of x equals, and they give you a polynomial, find f of 1. So it's basically like you're putting 1 in for x. So 3 times 1 squared plus 4 times 1 minus 5. Don't forget, this is kind of the thing I see here. If there's an exponent, you have to do an exponent first. Don't multiply 3 times 1 and then square 3. That's where you're going to have a mistake. So 1 squared is 3 times, 1 squared is 1. 1 times 1 is 1. So I'm going to go ahead and just show that step. Could you type this into your calculator left or right and get the answer? Yes. But I need you to understand what happens with the squared anyways in case it's something different than just a number. What if it's c plus 5? Right? Like you did in your homework. You'd have to write it twice in FOIL. So next we would get to multiply. 3 times 1 is 3, plus 4 times 1 is 4 minus 5. 3 plus 4 is 7 minus 5. So my answer is 2 for if the function of x was 1. If you put 1 in for x, you get 2 out of that. What if it was a negative 3? 3 times, because that's what my function is, a negative 3 squared plus 4 times a negative 3 minus 5. Again, PEMDAS, just way back when we learned that a long time ago. Make sure you do this first. So 3 times negative 3 times negative 3 is 9. Then you can go do your multiplying. Again, I'm okay with you using your calculator. It's just I say check yourself a couple times because if you're entering it in there wrong, I can't see what was happening in your head, or if you knew that you should have been doing the exponent first, okay? Can't see where maybe there was a sign issue. So I really recommend you always trying to do it, then just check yourself with your calculator just to, cover your ground and earn every point possible in the event of a small mistake. So 3 times 9 is 27. 4 times a negative 3 is a negative 12 minus 5. So 27 minus 12 is 15, minus 5 is 10. And then this one, if you'll just pay attention to plugging t in for x, then we would multiply it all by 3 if you need to kind of separate that so your eyes can understand what's happening. The t is the only thing that's replacing your x in the function. So this would be like saying 3 times t squared plus 4 times t minus 5. And then I'll show this 3 in this next step. So really what's happening is like if I take t squared, that's 3t squared, plus I can just get rid of those parentheses, 4t minus 5. So this 3 out front is probably when I would just remember, now I need to distribute the 3 to it. I just kind of pull it apart into 2 separate things and then distribute the 3 in the end. So distributing, I'm going to go underneath since I can't up here. So 3 times 3 squared is 9t squared. 3 times 4t is a positive 12t. And 3 times negative 5 is a negative 15. We're getting close. Just hang on for a little bit longer and you're going to be reviewed for the test. I'm trying to kind of sort of reteach as I'm reviewing, but I can only do so much, so it is kind of drawing it out a bit. Turn the page, and I think this is our last page. You okay over there, Ponka? Yeah? Just stretching? All right, let's look at 14. Find the domain. What does domain mean? Do you guys remember? X. So one thing that I like to think, it's like you're stating the restrictions. And we're going to do that in, once we find the domain, we're going to state the domain in interval notation. But basically what we want to know is what x cannot be, so we can find what x can be. That's pretty much what domain is, simplified as much as possible. So looking at letter A, that's just a polynomial, right? So there's not a restriction when it's just a simple polynomial, all other than I just know that all real numbers are possible. So the way that we denote that with interval notation is just to say from negative infinity to infinity. That's the domain of one that is just like a polynomial. It's not a fraction, it's not a radical. The only two things that are different are like fractions and radicals. Since b has a fraction, what can we not have in a fraction in the denominator? 0. So really all we're trying to figure out is what would zero out the denominator. So we set that x minus 2 equal to 0. And really solving means you're just adding 2 to both sides. So when x is 2, that's going to make that denominator a 0. Like, think about that. Like, plug it in. A lot of times, we get real close, but because we're trying to do it in our head and we don't just set it up because, we're so good, we actually accidentally call this like a negative 2 because you see a negative in it, I guess. I don't really know what happens, but there's mistakes that happen like that. When you plug 2 in, is 2 minus 2 0? Yes, that's what we're trying to figure out. Like, what would zero it out? So the only thing that x cannot be when we're talking about real numbers is x just cannot be 2. So the way to show that in interval notation and to help you with the number line, understand it, is x can be any number greater than 2, so it goes to infinity, and x can be any number less than 2, so it goes to negative infinity. So this one would be a union, It's just that you don't really see a gap. The gap is just the number 2. So that's why I try to put it kind of up there in the middle where the 2 parentheses turn. And you just have to make sure you're using 2 twice. So it comes straight down from the number line. So negative infinity, comma 2, and they both have soft parentheses. Union 2, comma to positive infinity. So these interval notations are always read left to right, so it needs to be smallest to the greatest, right? With the 2's kind of there in between. So you would write that in interval notation just like that. We do have a problem where you get to just tell me the slope. So remember, that's taking your second y, -1, minus your first y, which is a -3. So minus is in the formula, but your second y was also negative, so, or your first y was also negative. So you put it in the parentheses. In the denominator, you're taking your second x, -4, minus your first x, 6. So, -1 plus 3 is 2. -4 minus 6 is a -10. Can I simplify that? Yes, make sure you always reduce, because I don't want to have to take off 1 point. I know it seems like 1 point isn't a lot, but just look at it. Does that reduce? Yeah. That would be like a -1/5 would be the slope. We actually already did this one, so we're going to skip down to 17 and 18 and be done. Actually, we're just going to do 18. You'll have one that's written more like this one. So it's going to combine everything, that way we can finish this out today. So find the slope-intercept form of the equation of the line that passes through the point with coordinates 3, -1, and is perpendicular to the graph of this line. So this is an equation for a line, maybe going like this, and I need to find the equation of a line going like that, right? That's basically what's happening. So we learned about those relationships with slopes, perpendicular line, for this reason. So I know the slope of this line is -3/2. In my formula, I'm going to use 2/3. So because this one's negative, I'm using a positive, and I flip my fraction. Remember, if it said parallel, I would use this same slope, right? But because it says perpendicular, this is the one I'm using in my formula. So this is where you use the y minus your given y equals your slope times x minus your given x. So y minus my given y is a -1 equals my slope. I'm using the 2/3 times x minus my given x, which is 3. So now all we have to do is distribute and get y by itself. We need to answer in slope-intercept form. So y plus 1 equals 2/3x. 2/3 times a -3 is a -2. We need to do that cross-reducing. You can. So it's just -2, or you can plug it in your calculator. Last step, you just subtract 1 to get y by itself. So when we come over here, you're actually adding 2/3x minus 3. And so just for review purposes, it would be good that everybody goes back over their notes. If you want to turn on the back side of this paper, I'm just going to tell you, like for example, I did add a question to this test that talked about your vertical line test. You guys remember that? It's really not a hard concept. In fact, I did it because I thought it was an easy thing to remember. But the vertical line test, what is a vertical line test? You guys remember? So vertical line test, this tells me just by looking at the fraction if it's a function or not. That's basically what the vertical line test does. You know, so if you didn't know, so say you have a graph that kind of looks like this. Is that a function? How do we know? We do the vertical line test, right? We say, this is a function. And I'm going to ask you to kind of explain in just a short sentence. What could we say? We could say something like, using the vertical line test shows it only crosses at one point. And so we're supposed to know that that means that is a function. You could get more detailed if you wanted. You could just say vertical line test shows it crosses at one point, meaning only one x and one y value share a point, right? If they don't, Wonka, I hope you guys get 100% on this test with all that cyan. If you don't, if you have a graph like this, would this be a function? No. And again, you would just say not a function, and you need to tell me why. Because it crosses at 2 points, right? But just kind of try to make, when it crosses at 2 points, that means you have two y's with one x. If you think about that, if it's crossing here and here, that would be both of them have, like, let's maybe say both of them have x is 2, but maybe this is a positive 2 and maybe this is 2 negative 2. So that means they have two different y's for the same x, and that's what makes it not a function. You can't share a different y. So when we have functions, you get a specific, only one y possibility out of an x. They're soulmates, okay? You can't break them up. Okay, only one specific y goes with one specific x. And that's what you were supposed to kind of learn when we were doing the functions. Okay? Just trying to take that a little bit deeper so you guys understand it a little bit more. So on Thursday,